Hi, I'm Brooke and I'm going to teach you how to implement a binary search algorithm. Please note that this algorithm only works with sorted lists. It's not going to work with an unsorted list, so if you want to have a search algorithm that searches in an unsorted list, this is not the algorithm you're looking for. So the first thing we're going to do is sort of look at what a binary search, what is binary search. So the first thing we need to know is that it sort of takes it searches in halves. It starts with the lowest index. So we have a variable that keeps track of what is at the lowest point of our search and at the highest point of our search. We also have something that keeps track of our midpoint of search, and that's the actual variable we are going to be checking every time to see if it is equal to the term we are searching for. And please note that the high and lowest points in this search method change throughout the actual algorithm. So to get started on what that actually looks like, we can first define the function. Let's just call it binary search. And we're going to take in a list. We can just call it list1 and whatever value we're looking for. So the first thing we need to do is set our variables, the low, high, and the mid. So like I said, we're going to start at 0, our index 0. We're going to start, high is going to be the length of the list, and we want to make sure that it's the length of the list -1 because that will search because we start at 0. We also want to set our mid variable, and we're going to start that at 0. But we're going to set it once we get into the actual while loop. Speaking of while loops, the first thing we have to do is think about like why, what is our condition for actually running the program. So if you think about it, we're starting right here with our lowest, we're starting right here with our highest, and we're starting right here with our midpoint. If our midpoint is equal to the actual term we're searching for, we can just return that. Otherwise, if we, this should be a 5, sorry, ignore that, this should be a 5. Otherwise, if there is, if this is higher or lower than the term, then we will edit the code. We will edit what we do with our high and low variables based on whether this is higher or lower than our term. So say we're searching for 3. What we're going to do is set this as low, set this as high, and set this as mid. Since 4 is greater than 3, we're going to reset our midpoint to equal whatever is the midpoint of between these two numbers. In which case I believe it's either, I think it's 3. So it should be caught in the next one. And then we're going to reset our high variable to equal 4, or this index, which is 3 minus 1. So the index of whatever this is, -1. So I believe mid will actually be 2, and the high will be 3, because we already checked 4. We don't want it to be 4 again. So after we go through once, we check to see that 4 is greater than 3. We move over mid, we move over high, and then we don't change low at all. We keep low as our low. So we're searching in between these two, and then we're checking to see if it is there. And this will make sense a little bit more. So what we're checking is while the low is still less than or equal to high. Because once we find the mid, then we can just return it. But if we eventually get to the point where low is equal to less than or equal to the mid, then we've crossed the low and the high. We've crossed over. So now they are no longer searching for the term. They're just like sort of crossing over each other, and we don't want that to happen. So that's going to be our while term. We haven't found it. We didn't find the term, so we would return something else. So let's do our while loop. So we have a while low is less than or equal to our high. because that's when we know it is crossed over. Cool, so that's our condition. The second thing we want to do is set our mid value, and our mid is just going to be the middle of whatever low plus high divided by 2 is, because that's the middle value of that. Low plus high divided by 2, and we want it to be doubles so it doesn't give us a decimal. Cool. The next thing we need to do is just check to see if the middle value, the list value in the middle, is less than the value we are checking for, or if it's higher than what we're checking for. So the first one we can check to see if our list 1 at whatever our middle value is less than our value. And if it's less than our value, so say we're searching for 6 and we want to get 8, if it's less than our value, then we want to move our low value to whatever mid is, to whatever our middle, what we just checked, plus 1. So we're going to be checking 8 after that. And it could be say the same thing about like 4. Like if we have, if our middle right now is at 4 and it's less than the value we're searching for, let's say it's 5, and pretend this is a 5 because I messed up. If what we're searching for is less than our value, then we move over low, which used to be over here, to equal this right here, plus 1. So this is our new low. And we can sort of see this play out by saying just like low is equal to mid plus 1. And that's all we need to do. We can keep the high. The high would be over here, the low's right here. All we need to do, the low's right here, the mid is in a new place, and the low is right there, and the mid gets reset every single time. So every time we go through while the low is still less than or equal to the high, we reset the mid. So we don't have to worry about moving the mid, but we have to worry about moving the low. So the low is in a new space, the mid gets reset, and then that's pretty much it. We're now checking a different set. The other conditional we have to think about is if the list, just like literally the next condition is if it's higher than the value. So if it's bigger, then we just change the high instead. So the high equals mid minus 1 because we're going, oh, that's lid. I was wondering why it was giving me an error. So we do the high if we're checking for 2. I don't know, let's say we're checking for 6. Like this is our mid value 4, and it is, or let's say this is 5. This is our mid value 5, and it is greater than the value we're searching for, which is 2. Then we want to change the high, which is right here, equals the mid minus 1. So whatever this was, and it's now here. So we're checking in between these two. Index 0 and index 3 instead. Otherwise, once it's found, since our while condition hasn't been met yet, all we need to do is return mid. And once it finds it, we're checking the entire time to see if the low and the high, just editing the low and the high, and we're setting the mid equal to the lows plus high over 2, and we're just checking our while loop. The entire time we're just seeing if the low is less than or equal to high. And if we find it, then all we need to do is return mid. So pretty simple. Otherwise, if we don't find it, if it's not in the list, we can return something else. So in this case, we can return -1. And if it returns -1, then it is not in the list. So let's do a couple of examples. So binary search. Let's do a list of like just like a regular 3, 4, 5, 6, 7. And it is important to note this will return the index returning mid will return the index of what this is at. So it should be one less than what we're searching for. So let's do like a regular, let's also do just 1, 2, 3, 4, and I totally forgot to give this one an actual value. Let's search for 8. And in here, we're going to search for 1. And then let's try this. Let's do one more, and in this case, we're going to be searching 1, 2, 3, 4, 5. We're going to be searching for 8. Or actually 1, 3, 4, 5. We'll search for 2. Cool. So just to show you what that looks like, let's run it. Beautiful. And it looks like it gave us what we wanted. So through this list, which has 1 through 10 as our as our list items, we're searching for 8. And since we start at index 0, we're going to find it at index 7, which is our answer. And right here, we're searching for 1. It's going to be at index 0, which we also wanted. And here, we're searching for 2. It did not end up being found, so we returned -1 instead. Okay, I hope this was helpful in learning how to implement the binary search. Hopefully you learned something, and hopefully this helped you with whatever you're trying to solve. Okay, thanks for watching.